In this video, I'm going to talk about Condrieu, which is a testnet using verkle trees. This testnet is a single client testnet, and it uses a modified version of Geth. So how is it different from other testnets? Well, for one, it's using verkle trees. In fact, it's using one verkle tree because the account tree and the storage trees are all merged into a single tree. And it's also producing stateless blocks, so blocks with extra information that we're going to detail. The general idea about verkle trees is that they are wider, more shallow, and they make for smaller proofs. So this change overhauls the complete storage model. So all the properties of an account are not condensed at the same location. They can be found in different leaves, and every leaf is 32 bytes. The block format has also changed, and the idea is that you add two extra fields to the block. One of them is the list of all the key values that will be changed during the execution of the block, and the proof to ensure that those key and values are correct. This is a very exciting improvement because with this, the clients will no longer need to spend a lot of time syncing before they can actually participate in the network. I have a MetaMask install that is connected to the Condrieu testnet here. I have some testnet funds that I got from the faucet, and then I also have an install. I also use Remix to create some smart contracts. For example, storage. It's a simple storage contract that I can go and compile. When it's compiled, I want to deploy it, so I use the injected Web3 so that I can connect to my MetaMask install, and I click deploy. So MetaMask reacts and tells me, do I want to confirm this transaction? I do. And then I will wait, and the transaction is already confirmed. So the contract has been deployed. I can set whatever value I want, and I will send a transaction, accept it, wait for it to complete. It might take some time. It's already done. And then I can retrieve, and I can see that this is the decimal value for that hexadecimal value that I just set. So I can go to the location where my contract got deployed, where the constructor got called, and I can see that its number it's been deployed in block number 50422. So I can use my mini block explorer here, click on block 50422, and I see a lot of information. Some of it is classic, like the Coinbase, the gas limit, and the gas used. And then there's some information pertaining to the stateless block. So the first thing is this picture that represents the stateless tree. So it's not the entire state, it's only those leaves that got modified during the execution of this block. And you have two leaves that got modified. There's the balance for the Coinbase because it got incremented, and there's the address at which the contract was created. It's a small contract, so there's only one leaf. And then there's the list of extra information provided in the witness. I don't really want to go over those details right now, but it's there. And you can see in the end there's a transaction list, so there's only one transaction, the contract creating transaction. So that worked. So what are the next steps? Well, Geth produces stateless blocks that can be executed statelessly, but the execution in Geth is stateful. There is a collaboration happening with Ethereum.js in which we will make Geth produce stateless blocks statefully, and have Ethereum.js execute those blocks statelessly. So that's very exciting, because once this is done, we have the complete proof of concept. And on the get side, we're going to modify the synchronization algorithm, the state synchronization algorithm, to use the data in those blocks instead of spending hours, if not days, trying to download the data to then be able to join the network. So that's it for this demo, and hopefully we'll have a lot more good news soon.